In this video, I want to try to clarify some of the binary principles we talked about in last night's webcast. So humans use a decimal system to count, or a base 10 system. We use numbers 0 through 9. So 0 through 9 is 10 numbers total. And if you combine these numbers in any order or any amount of these numbers, you can create any number in the decimal system. Computers use base 2 system, or a binary system. They only use ones and zeros. Think of computers as only having 2 fingers if you want to think of a physical representation. They have 1 finger on each hand, but we have 10 fingers, right? So we can count 10 different numbers, 0 through 9. They can only count zeros and ones. The reason why they're fast is they can process so much more information than us in the same amount of time. They get to do much more math, even though their math is smaller amount of numbers they can use. They can process stuff so fast with zeros and ones that they just blow us away in some ways. Note that the 0 and the 1 doesn't actually equal a 0 and a 1, and we're going to show you how to count in binary. So it's important to think, binary, 0 is more of an off. Think of a light switch being flipped down, or false, that something's not happening. And then 1 represents true or on. It's like a light switch flipped up. So if you take a light switch and you flip it up, the light turns on. If you flip it down, it turns off. So binary, the 1 and the 0 is a lot like that. So this chart might look a little weird, but if you think about it, 0 plus 0 equals 0. 0 plus, this is 1 equals 1. But now that we have a 1 in the 2 column, it's on, and the 1, in the 1 column is off. 2 plus 0 is 2. And finally, both of these are on. It has a 1. So 2 plus 1 equals 3. Is that weird seeing it with decimal numbers in there? Think about it with on and off instead. So if there's no 2 and no 1, it's 0. If there's no 2 but there is a 1, it's 1. If there is a 2 and there's no 1, it's 2. And if there's a 2 and a 1, that's a 3. They add up. So going back here, if you think about it as addition, it might make more sense. That 1 and 0 is just like a switch. Is 2 present? Is 1 present? Are they here to add together, or are they not here? So just to kind of break this down a little more, if we have a 2 and a 1, that adds up to 3. This is the way the computer would think. 1, 1 in binary is equal to 3. Now, with that same principle, this might look a little intimidating, but like we said last night, the chart will double the more you go to the left. So if you want something more complex, to see that rule applied, 1, 0, 1, 0, 0 equals 20, because 16 on, 8 off, 4 on, 2 off, 1 off, that just means 16 plus 4. So if we want to break this down, into another simple one, if we say 0, 1, that equals 1, because that means 2 is not present and 1 is present, right? That equals 3. If 2 is on and 1 is off, that's going to equal 2. So over here, let's make sure we reflect this. I forgot to do that on the first example, but 1, 0 equals 2. That's 2 plus 0 equals 2. So if we keep it thinking about it as ons and offs, let's do that. On, and this is off. That's only a 2 present. But now if we turn this one on as well, we got a 3. 1, 1 again, we're getting back to this example, is 3. 2 plus 1 equals 3. And that matches the chart up above, the bottom examples. So if you have a takeaway from this, even if the math is a little confusing, please don't be intimidated, because the rest of what we build will still make sense. Even if you can't count in binary completely, as long as you know that 0 is false and off and 1 is true or on, you should be able to get the rest of what we build. Binary is a very complicated subject, and we want to expose you to it and just let you know that what we're going to build functions more like a computer and less like a human, and that we're going to be dealing with ons and offs, and the computers, the things we're going to build, are going to be doing some math in the background. We want you to see all those logic gates and the math behind them, but you don't have to necessarily completely understand them to know how to use them. So as you progress building projects every session, you'll begin to better understand binary system. Again, this is something that they teach in college, and it's a really cool concept. And if you understand it, you know how a computer, thinks, essentially. But it takes time to get there. So don't feel any pressure. And if you need any extra help with this concept, please let Emma know. And, we'll be more than happy to, help you guys with a few examples outside of the class time.